Hello everyone, this is Sri Guru over here. Welcome back to my YouTube channel. Today in this video we are going to discuss about the position time graph for a uniform motion. For that, let us consider a particle is moving and we are going to draw a position time graph for that moving particle. First, initially I am choosing along the y-axis for the position. And along the x-axis I am choosing time, right? This is the origin, right? When time t is equals to 0, the position of the particle is somewhere at here, right? As the time go on increases, the position time graph is, we get like this. Right. Now, let us consider what happens if we take the slope of this graph. Slope of this graph. Let us take the 2 points which joins or they intersect like here. This one is A, B, C. Name these points, right? This slope is AB divided by BC. This AB divided by BC, right? How we can take this? How we can calculate this AB? With respect to A, the position of the particle is x2. Sorry, this is y2 for y-axis. And for this is with respect to here. This is y1, right? Similarly, for x-axis, the position on y-axis for the particle B is T2, and for the C1 the position for on the x-axis it is T1, right? Is it right? To get AB we should do first y2, it is a greater value minus of this y1 whole divided by, this is what BC, T2 is greater, T2 minus, this one is T1, right? Is it right? That means there is a change in the position, right? y2 minus y1 divided by T2 minus T1, or simply write this as delta y by delta t. What this delta y and delta t are representing? Delta y is representing change in the position. Divided by what this delta t is representing? Change in the time. Right? Therefore, this delta y divided by delta t is representing change in the position divided by change in the time, that is velocity. Velocity or speed, right? Generally we represent this as a speed. Okay, now take down or take the snapshot of this board. Whenever we take the slope of the position time graph for a uniform motion, then we will get change in the position to change in the time, that is speed. Okay, take them. Here this is a uniform motion, and the next one is non-uniform velocity. When we can say that the object is non-uniform velocity. Non-uniform velocity is nothing but the change in the position or the change in the displacement, equal displacement in an equal interval of time, right? If that equal displacement takes place in all the equal interval of time, the object is said to be uniform motion. Now we are going to discuss about the non-uniform motion. Non-uniform motion means if the object is moving with an equal displacement with non-equal interval of time, that means this is the particle moving from the position A to position B. Is it right? It is overall 4 kilometer, right? This is 1 kilometer, this is 2 kilometer, this is 3 kilometer, this one is 4 kilometer, right? The object to travel the first kilometer, all these are in a equal distances, and the object is moving in a one direction, right? If the particle takes a time to cover the first displacement in a 5 minutes, right, then the velocity v1 is 1 kilometer divided by 5 minutes. This is the first 1 divided by 5 kilometer per minute. The same particle travel the second displacement 1 kilometer with a time of 4 minutes. The displacement remains the same, but it takes the time by 4 minutes. 4 minutes. That means velocity is changing, right? Because the velocity is increases. Similarly, to travel the another length 1 meter only, but it covers with this once again with 3 minutes, then it is 1 by 3 kilometer per minute. Now look at it covers a equal displacement in an unequal interval of time. This is a non-uniform velocity. Non-uniform velocity, right? Note down or just remember the point. What do you mean by non-uniform velocity? The first one is variable velocity. Variable velocity. Variable velocity is, just I discussed here, if the object covers with a different velocity with a different distances, then it is non-uniform. Or otherwise, if the object is continuously changing its direction, then also it is called variable velocity. Either the velocity is changing or the direction of the particle is go on changing, right? Then we can say that the object is moving with a variable velocity, as we discussed in this example, right? The next one is average velocity. average velocity. Average velocity, that will represent this as v bar. Okay, this is a symbol to represent average velocity. It is just total displacement divided by total time. This is the average velocity, right? If you solve some problems based on this average velocity, then you will come to know that what is the meaning, actual meaning of the displacement. Okay, just first remember the average velocity definition. It is just change in the position divided by total time, or the displacement divided by time. V is equals to delta x divided by delta t. Correct? As we discussed in earlier. Then what do you mean by instantaneous velocity? Instantaneous. For that, let us consider a particle is moving with a different velocity, and that for that I am going to right here along the x-axis I am choosing the time, and along the y-axis I am choosing the position. Okay, and because of the particle moving with a variable velocity, just I will draw the diagram like this, right? What actually required? First, velocity. Velocity, as we discussed in the previous concept, change in the displacement, or displacement divided by time, right? We require this position. This one is a point P1 and this one is a point P2, right? And this is the displacement of the particle. If this one is P2, just take this as a P1, right? P2 minus P1 with respect to this y-axis divided by, this is time t2 and here is a time t1. Therefore, it is t2 minus t1, right? As we go on reducing the time interval, that means next immediately that I will take the point P to here. The time will reduces to here, right? The displacement is also get reduces, right? Further, we go on reducing the time here. Next, the P2 will come to here. If you further reduces the time, this, and finally here, finally it reaches here. That means this P2 minus P1 is that change in the position to the change in the time. The time is go on reducing at particular time of instant. That means we have to apply the limit as delta t tends to 0 to this equation, that instantaneous velocity, that is limit of delta t tends to 0 to delta p divided by delta t, which gives dp by dt. What is dp? That is change in the position to the time. That is what we call instantaneous. That means the velocity of the particle at that instant of time. That is instantaneous